Hello students, welcome back to Organic Canvas. In the last set of videos, I have explained what is the nomenclature of different functional groups. In this video, let's discuss one of the important topics in organic chemistry, that is isomerism. For both class 11th and 12th and other competitive exams, this topic is very important. So let's get started. What is isomerism? Isomerism is a phenomena where the molecules have same molecular formula but different properties. What properties? Chemical and physical properties. The melting point, boiling point, the acidic strength, basic strength, all these refers to the physical strength. And when we say chemical properties, that means chemical reactions. Well, they undergo oxidation, reduction, etc. Now, let's take example in order to understand isomerism better. For the molecule with molecular formula C4H10, the structure could be CH3, CH2, CH2, CH3. And this is nothing but an butane molecule. Alright. This molecule can also be written as CH3, CH, CH3, CH3 like this. And this is called as isobutane. If you observe carefully, for both the molecules, there are 4 carbons. And how many hydrogens do we have here? We have 10. So 3 plus 3, 6 and plus 4, 10, right? Same here also. You see, there are 4 carbons and 10 hydrogens. That means what? They have the same molecular formula, that is C4H10, but they are exhibiting 2 different structures. And these structures are called as isomers. Isomers have the same molecular formula but different structures. Due to this different structure, they will have different properties. For example, this N-butane molecule will have more boiling point than the isobutane, and boiling point refers to the physical property. The isomerism phenomena is broadly classified into structural isomerism and stereoisomerism. This is based on the bond connectivity. What exactly it means? When the molecules have the same molecular formula but different bond connectivity, then we call them as structural isomers. Now the question is, do the molecules have same bond connectivity? No, they don't have a same bond connectivity. The bond connection is different. Then we get the structural isomers. Yes, if they have same bond connectivity, but the three-dimensional arrangement of the atoms is different, then we call the molecules as stereoisomers. The structural isomers are further classified as chain isomers, positional isomers, functional isomers, metamers, tautomers, and ring chain isomers. And stereoisomers are further classified as geometrical isomers and optical isomers. Let's discuss all these isomers one by one. What are structural isomers? The structural isomers, as I explained earlier, they have the same molecular formula but different bond connectivity. What exactly it means? Let's understand this using chain isomers. The chain isomers have the same molecular formula but different number of carbons in the principal chain. That's why we call them as chain isomers. In the longest chain of carbons, right, there will be different number of carbons. For example, let's say C5H12. This is the molecular formula. We can write this molecule as N-pentane, right? So in the longest chain, how many carbons we have here? 5 carbons. Now, we can take this methyl, right, And then we can substitute that by a hydrogen present here. So what does that mean? It looks like this, right? They have the same molecular formula, but the bond connectivity from here to here, it is different. That's why we call them as structural isomers. Why they are called chain isomers? Because here in the longest chain we have 5 carbons, and what about here? We have 4 carbons in the longest chain. Now, is there any other possibility? Yeah, there is one more possibility like this. Check here, the carbon is attached to 4 carbons. That means there are 5 carbons, and we have 3 carbons, the 3 hydrogens on each carbon present here. That means what? There are 12 hydrogens. And in the longest chain, we have 3 carbons like this. So here we have 5 carbons, here 4 carbons, and here we have 3 carbons. In that case, we are going to call them as chain isomers. Many students ask me that, do we have any formula to determine how many isomers are possible for a given molecule? No, that is not possible. It's something you have to practice and you have to learn. Okay, so let's try one more example. C6H14. I'm writing a higher homolog. That means what? You have to add CH2 to this. So let's write the possible structures. Always start with the N isomer. That means N-hexane. You see there are 6 carbons. 1, 2, 3, 4, 5, 6. Right? And then you can start branching this. You see the methyl is being shifted to this carbon, or you can take from here and then shift here, either way. Okay, then what we can do, we can change the position of this over here like this, right? I can't write it over here because it's the same molecule, right? Same as this, so that's why. Okay, now you see here there are 4 carbons and then 2 methyl. You can write those 2 methyl on the same carbon like this. Okay, so like this you have to write possible structures. But now the question is, what is the relation between these two? They are chain isomers because the number of carbons in the longest chain is 6 and 5 here. You can't call these as chain isomers because the number of carbons in the longest chain is same. What about here? The number of carbons in the longest chain is 4. In that case, they are chain isomers. This is how you determine the chain isomers. What are positional isomers? The positional isomers are the molecules with the same molecular formula, but the position of the functional group will be different. Students, remember, for all the isomers, the definition must start with the molecules with the same molecular formula. Okay, so that's what the isomerism phenomena is all about, right? So now let's take example of C4H8. Right? So that means what? There is a double bond in the molecule. So how do we write that? You see here like this, or you can write like this. So what is the name of this molecule? It is 1-butene. If you don't know how to write the bond line structures and the names of the molecules, you can watch the videos. I have given those links in the description section. So for this, the name is 2-butene. Like this. So when you say positional, that means what? The position of the functional group must be different. Okay, so here the functional group is double bond. So its position is different. That's why it's easy to remember. Okay, now let's take one more molecule. I'm taking a halogen, right? So the halogen here is chlorine and there are 3 carbons. So how do you write this? C3H 3 plus 2 plus 2. That means what? There are 7 hydrogens and then there is a chlorine. We can shift the position of the chlorine on the second carbon like this. So what will be the name of this molecule? It is 1-chloropropane or N-propyl chloride. Or what is the name of this molecule? This is 2-chloropropane. Or you can simply call this as isopropyl chloride. That is a common name. Now, what is the relation between these two? They are positional isomers as the position of the functional group is at first and second carbon respectively. Now, what are functional isomers? These are the molecules with the same functional group, but they exhibit different functional group. Let's take C3H6O. For this molecular formula, you can write it as CH3CH2COH. If you want, you can write the bond line structure also. Either way, both are correct, okay? This is nothing but a propanal molecule, right? 1, 2, 3 and aldehyde. Therefore, this is the aldehyde molecule, propanal. For the same formula, you can also write it as CH3COCH3. I will write the bond line structure also like this, right? And what is this? This is a ketone, right? Where the carbon is attached to two carbons here. The functional group, that is carbonyl, is attached to two carbon. What about here? Carbon and hydrogen. That's why these are two different functional groups, aldehyde and ketone. They have the same molecular formula but different functional group. So what do you call them as? Functional isomers. It's there in the name itself. It's very easy to remember that way, right? Let's write down one more example. Say C2. We can write simple one, okay? C2H6O, right? Here C3H6O, that's why there is a double bond. Here it's completely saturated. How do you know that? For that you need to know how to calculate degree of unsaturation, right? If the degree of unsaturation is 1, you have to write a double bond in the molecule. If it is 0, you don't have to write the double bond in the molecule. So for degree of unsaturation also, I will give the link in the description section. You can always watch the video, right? So now CH3, CH2OH, right? You can see there are 6 hydrogen and 2 carbon. Also, you can write this as CH3OCH3. You move this here. The bond connectivity is different, right? So that's why they are structural isomers. And what is this? This is an alcohol. Alcohol. Ethanol, right? What about this? This is a ether. Dimethyl ether or methoxymethane, either way, right? But there are two different functional groups, hence they are functional isomers. Metamers are the special type of structural isomers where the molecules have the same molecular formula and same functional group, but they differ in the arrangement of the alkyl groups around the functional group atom. Let's take example of ethers. Students, remember, not all molecules will exhibit metamerism. Only certain functional groups like ethers, esters, secondary amines, right? So these are the molecules which exhibit metamerism. For example, an ether molecule with two ethyl groups can also exhibit one more ether where one side we have methyl, the other side we have a propyl. That means what? The molecular formula for both the molecules, it would be C4H10O. But the groups across this functional group is different. So there are two ethyl and there is a methyl and propyl. But the functional group is same, that is ether. And we call these special molecules as metamers. Let's take example of esters. The ester functional group is COO, like this. Say we take ethyl over here and then ethyl over here. So this is a functional group, right? Ester, and we have ethyl here and ethyl here. What if we take methyl here and then here propyl? So that means what? They have the same molecular formula, same even functional group, that is ester, but the groups across, they are different. So in that case, they are metamers. We can even take secondary amines also. What do you mean by secondary amines? First, see, whenever we have a nitrogen, right, attached to one hydrogen and two alkyl groups like this. So we have ethyl and ethyl here. So this is also called as ethyl ethanamine, or we can take this as propyl this side and methyl this side. So methyl propanamine. So again, the functional group is same here, but the groups across the functional group are different. Tautomers are the special type of structural isomers with the same molecular formula which are in dynamic equilibrium with each other. What exactly this dynamic equilibrium refers to? Say, let's take two molecules A and B. When we say equilibrium, the A will convert to B and B will convert to A rapidly. And it happens on its own. We don't have to do anything externally. The molecules are interconvertible rapidly on their own. And we call this phenomena as tautomerism and the molecules as tautomers. Now, will all the molecules exhibit tautomerism? No. Only certain molecules exhibit tautomerism. Then how do we know? For this, I will give you a simple trick. Whenever we have a molecule with this condition, what is the condition? There are three atoms X, Y, Z. There is a double bond between X, Y, right? And single bond between Y, Z. And there has to be a hydrogen attached to the Z atom. It converts to, look at this, the double bond is moving between Y and Z now. And what about the hydrogen? The hydrogen will shift to the atom X. And again, what happens? The H will move to the Z and the double bond will shift here. That means what? We are getting back the same molecule. It reverts. So this is a rapid conversion and we call this as in dynamic equilibrium. Let's take certain examples and understand this. Let's take ethanol molecule. What is ethanol? It is an aldehyde, right? With formula C2H4O. So the formula is, molecular formula is C2H4O. This is the molecule. Now, how do you identify whether this will undergo tautomerism or not? As I told earlier, identify X and Y is attached to Z. Is Z attached to hydrogen? Yes, right? Let's write it like this. Okay, we need only one hydrogen, right? So now what happens? It will undergo tautomerism. So how do you write its tautomer? Very simple. Between Z and Y, you form a double bond and here single bond and the shift of hydrogen is taking place like this. And what do you call them as? Tautomers. Right? And this is an aldehyde. So aldehyde and this is enol. Enol. So aldoenol tautomerization. Like this, even molecules like ketones do exhibit the tautomerism. So what is the driving force here? The driving force here is oxygen is an electronegative element. So because of this, what happens? It wants to take away the loosely held pi electrons, right? So because of this, the shift of hydrogen is taking place. And the phenomena is tautomerism and the molecules are called as tautomers. Students, remember, none of the structural isomers are interconvertible except for the tautomers. Suppose if you have a chain isomer like N-butane, if you want to convert it to isobutane, right, you have to do series of reactions or at least one reaction to convert this to this or this to this. They won't happen on their own. But whereas tautomers, they can interconvert on their own. The last set of structural or constitutional isomers are ring chain isomers. As the name suggests, a molecule can be a ring or a chain and they have the same molecular formula. So that's why they are called as ring chain isomers. Students, remember, in order to exhibit ring chain isomerism, the molecule must have at least 1 degree of unsaturation. The formula to calculate degree of unsaturation is 2C plus 2 minus H plus N minus X divided by 2, where C is the number of carbons, H is hydrogen, N is nitrogen, and X is the halogens. If you get degree of unsaturation as 0, then you cannot write ring chain isomers. You should get at least 1 as an answer. Only then you can write the ring chain isomers. Let's take example of C3H6. First, calculate the degree of unsaturation. There are 3 carbons, right? And then how many hydrogens do we have here? 6. No nitrogen, no halogen, so you can ignore that part. So when you solve for this, you're going to get it as 1. That means what? Without writing a double bond, you cannot write the structure of the molecule now. And what is this? This is a propene molecule and it is an open chain structure. Can we write a ring structure? Yes, we can write a ring structure. It's nothing but a cyclopropane. Either you can write like this or simply the bond line structure. So this is the ring structure. And what is the relation between these two molecules? The relation between these two molecules is ring chain isomerism. Let's write some more molecules for ring chain isomerism. Let's understand this ring chain isomerism with few more examples. C4H8, the degree of unsaturation is 1. That means what? You can write a open chain molecule, that is butene, or a ring structure like cyclobutane. Don't write the double bond again in this molecule. For cyclic structure itself, the degree of unsaturation is 1. That's why. Let's take one more example with the heteroatom. Say C2H4, the heteroatom here is oxygen. So either you can write it as CH3COH, which is nothing but ethanal, it's an aldehyde, or you can write oxygen as a part of a ring. And what do you call this as? This is called as epoxide. It is a cyclic ether called as epoxide. And what about this? This is ethanol. And what is the relation between them? They are nothing but ring chain isomers. Of course, the functional group itself is different, but the main difference is this is an open chain and this is cyclic. So in that case, they are ring chain isomers. Students, more the number of examples you solve from isomerism, you will have a better understanding. So let's solve some examples based on all the different types of structural or constitutional isomers. I'm going to solve these two examples in order to understand isomerism better. The first question is, what are the structural isomers for the molecular formula C4H9Cl? First, always calculate the degree of unsaturation, right? 2C plus 2 minus H minus X divided by 2. Substitute the values, you are going to get the value as 0. That means what? There are no double bonds in the molecule. Now, write the structures, and I always recommend writing the bond line structures as it will be easy. So this will be 1-chlorobutane. You can write 2-chlorobutane. Don't write the 3-chlorobutane because it's nothing but 2-chlorobutane. It's just a wrong nomenclature, right? And then you can start doing the branching. So it's isobutyl chloride, right? And then at the end, you can write a tertiary butyl chloride. You can see these are positional isomers, and then they can be either the chain isomerism also, where the number of carbons here is 4, here it is 3. But they don't exhibit the functional isomerism because you see the halogen is halogen. It cannot form any other functional group. Hence, these molecules will not exhibit functional isomers. They won't even exhibit metamers and of course the tautomers. Now, the next question is, what are the possible ethers for C4H10O? Again, you can calculate the degree of unsaturation. For this also, you're going to get the value as 0. That means what? No double bond or ring in the molecule. For ethers, we should always write the oxygen between two carbons. So how many carbons we have? 4. So altogether there are 4. You can write ethyl, ethyl, or a methyl and propyl. And remember, whenever we have propyl, you can always write a isopropyl like this. As I told earlier, there is no formula to calculate the possible isomers. It's always trial and error. You have to practice, only then you will get the right answer. Let's solve some more examples. What are the structural isomers for C4H8 molecule? The degree of unsaturation for C4H8 is 1. That means what? You can write open chain and ring chain structures. Since there are 4 carbons, right? So you can write a double bond between first and second carbon. So this becomes 1 butene. You can write even 2 butene. 3 butene doesn't exist, right? And then you can do the branching also. This is called as isobutene. So these are the 3 constitutional or structural isomers for open chain. Many students tend to forget about the ring chain isomers. So please remember, if degree of unsaturation is 1, make sure that you are going to write a ring structure. Since there are 4 carbons, you can write cyclobutane, but you can also write a cyclopropane. This is also a possibility which many students forget. So it will become methyl cyclopropane. So these are the 5 possible structures for the C4H8 molecule. The next question. Write the tautomer of cyclohexanone. So if you know the structure of cyclohexanone, it's easy now. Otherwise, it becomes impossible, right? Now, cyclohexanone is this. What I told you, just you mark X and then Y. Either you take Z here or here because it's a symmetrical molecule. It will not make any difference. Then what you have to do? You rewrite the structure as it is, right? Like this. And then between X and Y single bond, between Y and Z a double bond, and where the hydrogen will shift to, it will shift to X atom, that is nothing but oxygen. So if this is a ketone and this will be enol. Why enol? Because there is a double bond and an alcohol, that's why enol, and this is called as ketoenol tautomerization. In the next video, I'm going to discuss about the stereoisomers in detail. Thank you for watching this video. Until next time.